In this section of the course, we're going to apply what we've learned about exponentials and logarithms, and we're going to solve some equations that involve exponentials and logs. And in doing that, we're going to get a lot of practice on what we've talked about, and we're also going to learn how to solve some equations that we didn't know how to solve before. So let's go ahead and get started with that. Let's say we had an equation that looked like 10 to the power of x equals 7. How would you solve that? Well, traditionally, without using logs, you have no way of getting x by itself. But if you remember, the opposite of an exponential is a log, and also you can use some of the properties of the logarithm to help you. Let's try taking the logarithm of both sides. Remember, you can do anything you want to both sides as long as you apply it to both sides. So what you would have is log of 10 to the x equals log 7. Notice here I haven't put a base here, and that's because I'm just going to use base 10, and so it's implied. Okay. Log of 10 to the x, remember when you have an exponent inside of and you're taking the logarithm of something with an exponent, you can take that exponent out, so that becomes x times log of 10 equals log of 7. So now it's simple. You can just solve for x, and that's going to be equal to log of 7 over log of 10. But log of 10, okay, what does that equal? Well, this is an implied base 10 down here. So what it means is base first, 10 to the power of whatever it is I'm looking for equals 10. So 10 to the power of what equals 10? Well, obviously it's got to equal 1. 10 to the power of 1 is equal to 10. Okay, so that's what I'm going to use. So this is just equal to 1. So then finally x is just going to be equal to log of 7. And that would be the solution to this equation. You'd solve that. You could, of course, put this in a calculator and get a decimal, but this is the exact answer. Of course, when I say log 7, I mean base 10, obviously, because I haven't specified another base anywhere. What if you had an equation that looked like 3 to the power of 4 minus x equals 5? And I said solve for x. Again, I can take the logarithm of both sides. So I'd have log of 3 to the 4 minus x equals log of 5. Here I have an exponent inside here, so I can pull that out. So that's going to be 4 minus x times the log of whatever's left over, which is 3. Remember, this is just a property we learned at the beginning, equals log of 5. Okay, so I can say 4 minus x, I'm going to divide both sides by log of 3, is log 5 over log of 3. Okay. And again, I'm solving for x, so I can move the 4 over here. So I'm going to have negative x equals log 5 over log 3 minus 4. And to finally solve for x, I can just divide both sides by negative 1, which is going to change the signs over here. So x will then equal 4 minus log 5 over log 3. And I just changed the signs because I divided by negative 1. This would be the answer. Again, you could go in your calculator and you could plug these log 5, log 3, and then you could get a decimal, but this is the exact solution of this equation. All right, moving right along. We're getting a little bit more complicated with each problem. Hopefully that will build up to help you have some good skills here. 3 to the x plus 4 equals 2 to the 1 minus 3x. And I say, how do we solve for x? Well, again, I'm going to take the log of both sides, but it doesn't really matter if I take a log of base 10 or a log of base 4 or a log of base 3. As long as I take the log of both sides, I'm going to be able to pull this exponent out, which is what I'm trying to do anyway. So let me just mix it up a little bit and take the natural log, which is base e, remember, which is e is just a number, 2.7 or something. Natural log of 3 to the x plus 4 equals natural log of 2 to the 1 minus 3x. Okay, continuing on, what this allows me to do is it allows me to take this exponent and pull it out in the front, because remember, for my property, when you have a log of something with an exponent, I can do that. So what I'll have is x plus 4 times the natural log of 3 equals, and I'm going to do the same thing here, 1 minus 3x times natural log of 2. And that was the whole reason I even did this business with the natural log, was to let me pull the exponent out. Next, I'm going to distribute this natural log in, because I'm going to eventually solve for x. So I'll have x times the natural log of 3 plus 4 times the natural log of 3. I just distributed this into both terms, equals natural log of 2 minus 3x natural log of 2. Natural log of 2 times 1 is this. Natural log of 2 times negative 3x. This gives me the same old thing here. Notice I've got a term with x in it here and a term with x in it here. I've got basically a constant term here and a constant term here. I've got these natural logs in there, but don't forget, this is just a number. If you take natural log of 3 and put it in your calculator, you'll just get a number. So let's get terms on the same side of the equation. Let me move this over here by adding it. So I have x times natural log of 3 plus 3x natural log of 2. All I did was add this quantity over here. Secondly, I'm going to take this quantity and subtract it to move it over here. So I'll have natural log of 2 minus 4 times natural log of 3. All I did was subtract this from both sides. Notice I've got x here and x here, so I can factor x out, and I'll have natural log of 3 plus 3 natural log of 2. You can convince yourself that's true. X times natural log of 3 is equal to this. X times 3 ln of 2 is equal to this. That quantity will just simply be equal to the same thing I had before, like this. And in the end, it's easy to see, x is going to just be, I'm going to divide this quantity on both sides and I'll have x by itself. So that's natural log of 2 minus 4 natural log of 3 over natural log of 3 plus 3 natural log of 2. Okay. And you can continue trying to simplify this a little bit if you like. You could stop here. That's certainly fine to do. But you can also notice that I have 4 times natural log of 3. So I could continue on and say, okay, natural log of 2 minus, and I could put this back in the exponent, ln of 3 to the 4th power. Notice I can do that because as easily as I could pull it out, I could certainly put it back in. On the bottom, I'd have natural log of 3 plus natural log of 2 to the 3rd power. The only reason that you would ever be interested in doing that would be to kind of simplify things there a little bit. So you'd have natural log of 2 minus natural log of 81. 3 to the 4th power is just 81. And then you'd have natural log of 3 plus natural log of 8. 2 to the 3rd power is 8. So like I said, you could stop here, that's fine, but you can also manipulate it and you have a little bit fewer terms. So this would be the answer here. It looks complicated, but don't forget, natural log of 2 is a number, this is a number, this is a number, this is a number. So if you put them all in your calculator, you get some decimal, and that would be a number, and that would be the solution of that equation. But of course, this is the exact form of the equation. Okay, the next equation we're going to work on is log x equals 1 minus log x minus 3. Okay, what I'm going to do with this one is I need to get x by itself. Now notice in the other equations I had some kind of exponent like 10 to the x, and I wanted to get x by itself, so I did the opposite. I took the log, okay, and then that allowed me to kind of pull that out and go on like that. Here I have a different problem. I have the variable I'm trying to solve for inside of the logarithm. So I need to do the opposite. So what I'm going to do is I'm going to raise both sides to the power of 10. Or 10, I'm going to raise to the power of both sides. So what I'm going to have is on the right, same kind of deal, 1 minus log of x minus 3. So I'm going to have 10 to the log x, 10 to the right-hand side. I did the same thing to both sides. It's perfectly legal. Now on the left-hand side of the equation, what I have is this 10 cancels with this log. So I'm just going to have x on the left-hand side of the equation. On the right-hand side of the equation, I have to do a little bit more work over here. First thing I'm going to do is I'm going to write this as 10 to the 1 power times 10 to the negative log of x minus 3. Okay? Because I have the same base here, I can just add these exponents, which is what I started with. So that's totally legal. So I'm going to have 10, okay, times 10 to the minus log of x minus 3. The next thing I'm going to do is, up here I have negative log of x minus 3. So I'm going to kind of put that negative 1, which is a coefficient, out as an exponent. So I'll have x is equal to 10 times 10. And when I move this up here, I'm going to have log of x minus 3 to the negative 1 power. I had this negative 1. I just moved it out as an exponent up here, because if it were up there to begin with, I could have pulled it out. Okay? And then notice that I have a log and a 10 that kind of cancel like that because they're opposites. So in the end, what I'll have is x is equal to 10 times x minus 3 to the minus 1 power, because that's all that's left over. Okay? In order for you to do this cancellation, you need to make sure all these coefficients are gone. It has to be 10 raised to the log of something. You can't have anything else hanging out there, so that's why we had to move the 1 inside like that. Okay? So now what we have is x is equal to 10 over x minus 3. I just moved this to the denominator because it's a negative exponent. And I just cross-multiply. I multiplied both sides of the equation by x minus 3. So I'll have x times x minus 3 equals, this times x minus 3 is just going to give you 10 because it would have canceled with the x minus 3. So I'm going to expand this. This is x squared minus 3x equals 10. Okay, so then I can use a different color to go up here and say x squared minus 3x minus 10 equals 0. Okay, can certainly do that. And then now I need to solve this guy, okay, which I can do by factoring. I can put an x in my leading term here, as x times x will give me x squared. I can put 2 and 5 here because 2 times 5 is 10. The only thing I need to figure out now is where the negatives and positives go. 2 times negative 5 gives me negative 10. For the inside terms, I would have 2x minus 5x, which gives me my negative 3x, so that checks out. So then to solve this, I'll have x is equal to negative 2 or x is equal to 5. And just like always, I need to figure out which one of those are true or if both of them are true. Okay. The first thing you need to realize, though, is that negative 2, if you try to put it back in here, you'll have log of negative 2, and you'll also have log of another negative number in here. And the thing to remember is there is no such thing as the log of a negative number. If you remember, here is 1. The logarithm looks like this. So as you go closer and closer to 0, it just goes down, 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 negative infinity. But you can't take logarithms of negative numbers. So anytime you solve for something and it shows negative, just get rid of it. This is your one and only solution to this problem. What if you had log of 5x plus 1 equals 2 plus log of 2x minus 3. Okay. The question is, how would you solve that? Well, again, I've got my variables wrapped up inside these logs, and the opposite of a log is an exponential, so I'm going to raise both sides again with a power of 10. 5x plus 1 equals. Now, I'm going to raise the right-hand side to the power of 10, but I'm also going to write it like this, 10 squared times 10 to the log 2x minus 3. All I did was I raised the right-hand side to the power of 10, but because it's an addition, I can do it this way, because notice that since the base is the same, and I can just add these exponents together, and I'll get what I have there. So I just sort of skipped a little tiny step and wrote it a little bit different like that. Notice on this side, the log will cancel with the exponential, so I'll have 5x plus 1 on this side. That's the whole reason I did that. On the right-hand side, I'll have 100. That's 10 squared. Okay. And then this log is going to cancel with this 10. So I'm going to have 2x minus 3 on that side. So let's distribute the 100 in. 100 times 2x is 200x minus 300, negative 3 times 100 is negative 300. Okay. And then if I move this 200 over here by subtracting it from both sides, I will have negative 195x equals, and I'll move this 1 over here by subtracting it, it'll be minus 301. So minus 200, so 5 minus 200x, or 5x minus 200x gives me this, and then I'll subtract this, negative 300 minus 1 gives me this. X is equal to 301 over 195. I just divide both sides by negative 195. Of course, negative divided by negative gives me a positive. So this would be the solution. So basically, you identify when you need to raise the equation to the power to get your variable out. And don't forget that when you have addition like this, you can write it like this by splitting the exponent up into two different terms so that you can kind of simplify it as we have done here.